What's up, everyone? My name is Dr. Chris Hacks, and today we're going to be doing the CryptoPals Crypto Challenge, challenge number 8, detecting AES in ECB mode. So if you guys remember, we just implemented the encryption and decryption functions for AES and ECB mode. Now, in this challenge, we have to actually detect a block of text that has been encoded. So, in this file, there's a bunch of hex-encoded ciphertext. One of them has been encrypted with ECB. Detect it. Remember, the problem with ECB is that it's stateless and deterministic. The same 16-byte plain text block will always produce the same 16-byte ciphertext. So that is the problem with it. Therefore, what we can do is we can actually iterate over the entire ciphertext and look for blocks that are identical. And if it has, multiple identical blocks, then it's very likely that it's going to be an AES ECB mode. Now that's not 100% guaranteed. Like if you have a ton of data, let's say for example, you have a ton of data and it just so happens there's some repeated blocks that can throw it off. However, for the nature of this challenge, luckily these ciphertexts are all going to be different except for one that has been encrypted. So let's go through and find it. If I jump out of Visual Studio over here, so we already have it set up for challenge number 8. We already have our getLine function called so that our file is being read. So let's actually make our function to detect the block. So I'm going to come over here into my header, and what I'll do is I'll just do bool has repeating blocks. Okay, and we'll pass in a string, and I'm going to call it. Let me spell this correctly over here. Okay, we're going to call it ciphertext. And then we're going to have a key size. This will become useful later. So size key size. Perfect. Okay. So what we'll do is we will take key size blocks, store them in a set, and then we will actually go through and check to see if there's any repeated ones. Also, I'm going to include this. I believe it's unordered. Oops. Like that. Yes, because we'll be using that data structure in order to do our function. Alright, so if I go back to our CPP file, make some room here, and paste this. Alright, so what we'll do, first things first, we have to make sure we have enough data. In our challenge here, we always will, but it's good to have a check just for later challenges. So, if, we'll say ciphertext dot length is less than, we'll call it, oh, I put key size, I should say block size, huh? Block size, because we're looking at blocks, not keys. The key size and the block size should be the same. Okay. Let me also change it over here as well, just to keep things consistent. Alrighty. Alright, cool. If the key size is less than the block size, or I'm sorry, if the ciphertext length is less than block size, then there's not enough data. So, we'll return false. Alright. Perfect. Yeah, so we need to make sure we have enough data in order to actually do this. Now, what we can do is we can make a set. And this set, we will put all of our blocks in. Now, if you guys remember your data structure classes, sets will only be able to hold one element once. So we can basically insert the block. And if the block fails to insert, or we don't have the same size, we don't have the number of elements we actually think will be there, then we know it failed. Alright, so let's do this. We'll create an unordered set. And it will store strings, because we're just going to store our 16-bit blocks in here. And I will we'll call it unique blocks because we're looking for unique blocks. And then also, I want to know how many blocks we will have, so we'll call it num of blocks, and that will be equal to ciphertext dot length. Okay, cool. All right, so now we can actually iterate through our data. So for we'll use size ti equals 0. I is less than ciphertext. I'm sorry. I is less than number of blocks. That's why we just put this. And then, of course, I plus plus. All right. So first, let's get our block. So our block is just going to be ciphertext.substring. We're going to just grab it from the ciphertext. Subsurf is just going to be I times block size to block size, because that's how many characters we need. Okie dokie. And then if not unique blocks dot insert block dot second, then return true. So we're just going to insert our blocks into our data structure, and if we basically insert a block and it is the second time we insert that block, if it's like a duplicate block, then we know that it's AES. We know that it is going to be AES ECB mode. So, and if we don't find it, then we can just return false. So let me just go down here, return false. Okay, so this does rely on the initial plain text to have repeated data. Like there is an image, if you look on Wikipedia, which I will have linked in the description below, and I had it linked in the last video, but if you look in the Wikipedia pages for AES ECB mode, and you take like a picture, right? Like they have the Linux penguin. What will end up happening is you can still make out the shape because it's deterministic. It doesn't have any bleed over from the other blocks. Like if you have like a hashing algorithm like SHA-256, there is some bleed over from the rest of the data. This doesn't have that. So you can still see shapes and structures and stuff like that, which is why this repeated block check works. It only works on, large amounts of ECB data, but it will work for our purposes now. So let me go ahead and copy this. Go back to challenge 8. So what we'll do here is while we're getting our lines, we're just going to check. Let's see. So actually what I want to do as well is I'm going to have a vector of all of our strings that come back as ECB. So std vector, we'll call it, it's going to hold strings. And then we're going to call it matches. Okay. So while get line file line, if I'll just pass this in, has repeating blocks, we'll pass in our line. I will hex decode the line. Actually, for the nature of this, yeah, we should hex decode the lines because it's not gonna. The hex encoding is in 2 characters per byte, whereas we want 1 character per byte. So I do need to decode this. So hex to text, and I can push our line in. And then our key size, we'll just put 16. You can put it as a constant if you'd like, but it's not going to change. Okay, so if that's true, then we will do matches dot push back line. Now there really should only be 1 match, so I'm not going to reserve any space for this vector. You could reserve every single line if you really wanted to, but we don't need to because I already know there's only going to be 1 correct match. So we'll do that for every single line. And then what we can do is if let's see, I believe it is going to be matches dot size equals 1, then that means we found a match. So we'll return matches of the first object. Okay, so that's what we'll return, and else, I'll put else if, I guess I could use a switch statement here, huh? Let me do that real quick. It doesn't really matter, but if matches.size, we'll switch that. Oh yeah, I forgot I need to actually encase this in parentheses. It's been a while since I've had to do that. Okay, so case 0, and we'll do that. I guess I probably should leave it with the normal formatting. Case 1, and then default. Alright, so if there's multiple, we'll say multiple ECB encoded ciphertexts found, like that. Oh, I forgot I need my break statement. Oh, no, wait, this is return. Why would I need a break statement? Never mind. Okay. If it's only one, then we'll just say, or here, let me say this. 0 will be no ECB encoded ciphertext found. And then finally, we'll actually just return our ciphertext. So what I'm going to do is, we can return our ciphertext. I believe that it is encrypted using the same stuff as earlier. So I think it will be AES 128. Or let me include AES. I kind of need to include that header first. I'm not 100% sure about this. I know the authors of CryptoPals like to reuse their keys. Um, so it probably is encrypted with the same key from earlier. Did it need to be AES? There it is. Key is just yellow submarine. And I do have to take this out of hex. I believe that the authors do it this way. So let's just go ahead and run this, and I believe this should work. I know the repeating blocks will work. I'm just not 100% sure about the decrypt. I'm pretty sure it will be. Because, let's see what it comes back with. Oh, STD out of range. Okay, so great, great, great. Sounds good. That means something went wrong. So let's do a little bit of debugging. Okay, so I figured out the issue. I forgot to actually divide here. So we need to do ciphertext.length divided by block size. If I don't do that, then it won't work because we have to actually have the number of blocks. It was just passing in the ciphertext length, but if there's 32 blocks, but each block is 16 bytes, then it'll just go on for too long. So we need to actually account for this. We need to include this. Can't be having a size of 256 and broken up into 16-bit blocks, and we just go too far. But anyways, so we have this here. So that should fix it. Let's try running it again, see what happens. Okay. Is it going to start? There it goes. And decryption finalization failed. Interesting. Okay. All right. I'm guessing that the decryption isn't quite correct. Um. Yeah. Let me take a look. Let me do a little bit of debugging again and see what's going on. I'll report back. Okay, I realized what I did wrong. So I actually passed in the line, which will just pass in the last line that we just read. That one probably won't be the ECB encrypted text. So let's rectify that. We're gonna do matches at 0, and that should fix it. All right, one more time. One more time. It should be the last mistake. But yeah, if you pass in bad data, then it will throw an error. And hey, that's why we threw errors earlier instead of just returning a string. And it threw another error. Lovely. All right. Time for a little bit more debugging. All right. So what I realized, I could just be using the wrong key. It doesn't necessarily tell us to decrypt it, it only tells us to text it. So, we will leave it at that. I'm not going to worry about trying to decrypt it since we don't necessarily have the right key. You can play around with it a little bit. I mean, we will be breaking it later on, so we will find the key later. But for now, we are not going to worry about decrypting this one. All it does is tell us to detect it. So we detected it, we returned it. So if I actually run this again, this should give us the hex output, I believe. But yeah, so let's just run it, make sure everything runs correctly. And yes, there we go. So it does give us the hex output. So that's all we need to do for this challenge. In the next set, which we'll be starting soon, we just finished set 1. We will be starting set 2 shortly. But first off, we need to just have this good to go so that we can detect it later on, and then we'll actually break it over the next few challenges. So, thank you all for watching. I really appreciate y'all for tuning into our video, and I will look forward to seeing y'all in the next video. So thank you.